Hello, this is Ken McCrate, and I'm going to help you to solve for this math problem. And like some of the math problems that we've done before, the key thing here is go for what you know. So let's take a look at that. Now I know that I have this angle inside here, 45.5. Now keep in mind when you see a point, that means that that's in degrees, decimal degrees. I know that I have an inclusive angle of 89 degrees here. Inclusive means that's the total amount. That means from this point to this point. I also know that I have a 45 or 44.5 angle inside here, which is the same as this one here, and we're going to go over that. I know that I've got this 67 degrees here. I have 67 degrees here. I have 135 degrees here. These are all given angles. And I have 23 degrees here. Again, go for what you know. All right, so now that we've identified the things that we know, what else do we know that might not be quite so clear? Well, I know that I've got a radius inside here. Or I shouldn't say a radius, but a ball inside here. This ball goes from this point all the way around, this whole piece here. As you go through this, it goes all the way around, okay? And what is the distance of a circle? The distance of a circle is 360 degrees, right? Okay. What else do we know? We know, remember the rule that I taught you before, and that is any time that you have a radius and a tangent point, here's your tangent point right here, this 90 degrees right here. That means that it is congruent to the other side of the equal angle. So what is the other side to the equal angle? Well, let's take a look at that. We know that we have a distance from here to here that's going to be the same as the distance from here to here, right? Why do we know that? We know that, if I could drop this on there, it'd be good. There we go. We know that because we're working to the center line here, right? This center line right here. This is a center line right in this area right here, this whole area right there, okay? So we're working to that center point. That finds the center of the ball. The ball, if you had this in a V block, remember working with V blocks, let me draw one up real quick for you. So here's a real quick sketch of a V block. And what the V block does is it finds the center of the ball. Because when you drop the ball inside the angles, this is going to be along the same plane. Now the center plane here of this ball. So now the only way that that would change is if this angle inside here, this angle right here, and this angle right here wasn't the same. But why would you want to build a V block that doesn't have an angle that's the same? So what that does is it tells you that the distance from the center of this ball to this edge here, to right here, and the distance from the center of this ball to this edge here has to be the same. And they share the same plane. The same plane is the line that intersects the two angles, or the center line, okay? So let's go back to our problem. And what do we know here? What do we see? We see that we've got a distance from this center point to here, and this center point to here, that shares this same plane. That means the distance from here down to here. That's the plane that it shares, meaning this distance is the same as this distance, and it shares this plane. Okay? It doesn't share the outsides, but we know they're going to be the same. Why? Again, center of the ball on the center of the V. Whatever this distance is here, this distance here is going to be the same. Why? You've got the ball. That just goes from the center of the circle. So what does all that mean, Ken? I mean, gosh, you're going through a whole bunch of stuff here, and we haven't gotten any further. No, but this is the basics to solving for the problem. So that's what you want to know. So, all right. So without further ado, let's go ahead and take a look at the whole problem. Okay, so this is what we're looking at. We know that the distance from here to here is the same as the distance from here to here. We know that it shares the same plane, this blue line, and we know that we have 135 degrees total inside here. So if this is the same here, and this is the same here, and it shares the same plane, what you have to do with this is you take the 135 degrees that we have inside here and divide it by 2. That's going to tell you what the distance is, or what the angle is, from here to here, and then again from here to here if you divide it by 2. So 135 divided by 2 equals 67.5 decimal degrees. That's not 67 degrees 50 minutes. When you see this decimal point, that means that it's decimal degrees. So that's what we get for this angle inside here, right? So let's connect that right to that, okay? There's our angle. That's what that is there. And that's what this is right here, okay? All the same. 67.5 here, 67.5 there. So we know that all angles, and we're talking about just this one angle here, just this one section here, not the whole thing, just this one, all right here, like this, equals 180 degrees, right? So we got 180 degrees for all angles. If it's 180 degrees and we have 90 degrees right here, why is that 90? Again, anywhere where a radius and an angle intersect, that is a 90 degrees surface. And that is called a tangent point. Tangent, okay? That doesn't mean it's tangent as far as you would use that in a trig function. It just means it's touching it. It's tangent, kind of like tangent housing. Tangent housing is a house that's built onto the next house. It's built onto a next house. It's built onto a next house. So houses that are all touching each other. Okay, that would be tangent housing. All right, so we have 180 degrees. We're going to subtract 90 from that. Why 90? Where'd you get 90 from, Ken? Well, the 90 is from here. So let's go ahead and put that in there. And then we're going to subtract 67.5 degrees. Why are we doing all this? We're doing all this because we want to find out what this angle is here. And if we find out what this angle is here, it's going to be the same as this angle here is, the A2 angle. Now, it's hard to see that because I've got another line over top of it, but that's what that's going to be, okay? Now, if I'm looking for this angle here, is it going to be the same as the angle here? Absolutely. Would it be the same as this angle here? Absolutely. The same as this angle here? Absolutely. It doesn't matter how close you bring this to this point here, it's going to be the same angle carried all the way out. So if you take all of these together, you take 180 minus 90 minus 67, I believe that's going to be about 22.5, right? That means 22.5 degrees. That is not degrees decimal degree. That is not degrees, minutes, and seconds. That is degrees, decimal degrees, okay? Again, that is not 22 degrees, 50 minutes. That is 22.5. Do you want to get degrees, minutes, and seconds? Then just hit your second key on your computer, on your calculator. And then, and if you don't have a second key, this is an N. Sorry about that. It doesn't look good. If you don't have a second key, you probably have an invert key, INV key. Hit that key, and then hit the D dash DMS key. Decimal degrees to degrees, minutes, seconds. Decimal degrees, that's that. That's what we have here. To degrees, minutes, and seconds, and you're going to come up with, it's going to tell you that it's 22 degrees, 30 minutes. Okay, so that's what A2 is going to be, angle A2. All right, so write all of these down. You don't have to write down the whole angle. You don't have to write down everything that's in it. What I do want you to write down what it is here, 67.5. What it is here, 67.5. What it is down here, 22.5. Okay, and we're going to clear the screen. So now what we're going to do is repeat the same process for this angle inside here. We know that we've got the 67.5 for angle A1, right? Angle A1, 67.5. That means angle A3 is also going to be 67.5. Remember, they were equal to each other. So let's just kind of write these down just to kind of remember what we had. And that's going to be A1 and A3. Kind of a lousy one there. Okay, this pen slips sometimes, but you get the idea. That is angle 1, A1. That's there. And angle A3. And then angle A2 is going to be 22.5. Again, that is degrees, decimal degrees. It's not degrees, minutes, and seconds. So, can we solve for x now? Absolutely. Why? Because if x is the distance from here to here, and we know that's 67.5 there, and it's 67 here. Again, we're going for what we know. Just take 67.5 plus 67. And you're going to say, wait a second. How can this be 67 degrees here when this is 67.5 degrees over here? How? Well, they're the same distance from here to here, right? Right. They're the same distance from here to here, right? Right. But here's the kicker of it all. Does it share the same plane as this here? No, it doesn't. This plane from here to here, totally different, right? It's a different plane. It's not over here. It's over here. And that's the difference. So this can be 67.5 degrees. I mean, this could be 67 degrees. I'm sorry. This could be 67 degrees. And this could be 67.5 because it shares a different plane, or it has a different plane. It doesn't share this distance here. All right? All right, so if we know this is 67, and that's 67, and that's 23 right here, what's this angle going to be here? That'll be 23 also, right? Remember, everything has to equal each other. So, what are we looking at then? We now have angle A1, 67.5. We have angle A2 at 22.5. We have angle A3, 67.5. What still needs, oh, and we have angle X because we're going to take these two and add them together. So this is going to be 5 point, drop the 4 down here, carry 1, 6 and 6 is 12. That's going to be a total of 134.5. So X is going to equal 134.5 degrees, decimal degrees. Now, what else do they want to know? Well, they don't want to know anything else. You've got it all solved. You've got everything planned. You've got the whole thing in here. That's the whole problem in a nutshell. Now, would you be able to solve for this distance here if you wanted to? Why not? You know that you could take this 67 degrees here. You could take this 67 degrees here. You could take this 67.5 here and this 67.5 degrees here, or you could take the 135 degrees and add it to the 67 and the 67, and that would tell you what the remaining distance is from here to here, if you ever just needed to know that. How? Because you would take it not from 180, but from 360, because it goes all the way around the whole circle. So that whole circle comes all the way around here, right? comes all the way around. That is 360 degrees all the way around. And that's how you could solve for this. So when you solve for this, could you solve for this angle from here to here? Absolutely. Just take 360 and divide it by 2. I'm sorry, not 360 divided by 2. Just take whatever you come up with as far as what's remaining here and divide it by 2. And that would tell you what it is. Another way to do that is you know that you've got a 90 degrees inside here. Why? Because you've got a 90 degrees there, and because it's tangent. And you have 44.5 thousandths here. So if you have 44.5 thousandths, we're back to the 180 thing again. All right, so let's take a look at that. The 180 piece is right here, from here to here, and from here to here, and from here up. There's our triangle. Here's our 90 degrees right here. We know that we've got 44.5 degrees, decimal degrees, here to here. You can solve for this. And that'll tell you everything that you need to know. Remember, your distance from here to here is going to be the same as the distance from here to here, making them congruent. This distance down here, right here, it's going to be the same, right? From this point to this point. I hope that helps. Talk to you soon. Have a great day. Take care.